Hello again, everybody. Hopefully everybody is staying healthy. Section 5.2 is the order of business in this video here. Again, make sure that you view the YouTube videos that I posted before you look at these examples that I'm going to work out here. In section 5.2, we're going to continue to simplify expressions raised to exponents. So we're going to have to utilize our rules of exponents. And these expressions are going to start to have some negative exponents. And so we're going to have to also remember how to deal with negative exponents. Okay. Uh, I think a good place to start here would be to define what a negative exponent is. Suppose that in general I have some base raised to a negative exponent. Well, suppose that base is in the numerator, because I could place this over 1. To get rid of the negative sign on the exponent, which is something that we always like to do unless we're working with scientific notation, and normally we leave the exponents negative when they're supposed to be negative. But other than that, other than scientific notation, we always try to simplify our expression to do away with negative signs on exponents. So if I have a quantity in the numerator of a fraction raised to a negative exponent, to get rid of the negative sign in the exponent to make it positive, I have to reciprocate or flip the base down into the denominator. So in general, in this example, x to the negative nth power becomes 1 over x to the positive nth power. Okay. Likewise, if I had my base raised to a negative exponent appearing in the denominator of a fraction, to do away with the negative sign on the exponent, I would have to take the base and flip it or reciprocate it up into the numerator of the fraction. In which case this expression now would be x to the positive nth power over 1 here. Okay. All right, so let's look at a couple of examples. Suppose that we wish to simplify these. Suppose I have 3 raised to the negative 4th power, and I want to simplify this expression or evaluate it. Now, when you have a number raised to a negative exponent, you cannot evaluate it until you first of all get rid of the negative sign on the exponent and make the exponent positive. This whole quantity is understood to be over 1. And to do away with the negative sign on the exponent, we're going to have to think reciprocal. So this base 3 is going to have to be flipped or reciprocated down into the denominator, in which case this is going to be equivalent to 1 over 3 to the positive 4th power. So that is saying 1 over 3 times 3 times 3 times 3, and that gives us 1 over, now 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So 3 to the negative 4th power is really equivalent to 1 over 81. Here's another one. What if I have negative 6 raised to the negative 2 power? Well, to simplify this expression, again, we have to get rid of the negative exponent. Don't worry about this negative sign in front of the 6. We don't care about that. We care about the negative sign on the exponent. This whole quantity sits over 1. So to simplify this, we're going to have to take the 6 and we're going to have to flip it down into the denominator or reciprocate it down into the denominator. In which case, we're going to be looking at negative 1 over 6 to the positive 2 power. Okay, notice this negative sign just came over here, but the exponent changed from a negative to a positive because we reciprocated the base 6 down into the denominator. So further simplifying, this is really negative 1 over 6 times 6, which really gives us the final answer of negative 1 over 36. That's your final result. Now, parentheses can make a big difference as far as exponents are concerned. If I have negative 4 raised to the negative 2 power, okay, this is saying everything inside the parentheses must be subject to the negative 2 power. Inside the parentheses, we really have negative 4 over 1 understood. And so therefore, to get rid of this negative exponent on the outside of the parentheses, to make it a positive 2 exponent, we're going to have to take this base of negative 4 and flip it down into the denominator. In which case, we're going to then have negative 1 over 4 raised to the positive 2 power. Notice the negative sign in front of the 4 still is present after flipping the 4 down into the denominator here. And so what we would have here now is we're going to really have negative 1/4 squared, which is really saying negative 1/4 times negative 1/4 And a negative times a negative is really a positive. And 1 times 1 in the numerator is 1, and downstairs in the denominator, 4 times 4 is 16. So this really simplifies to 1 over 16. 1 over 16. Now, contrast that problem with this one here. What if we had the opposite of 4 to the negative 2 power? Notice the negative sign is not enclosed inside the parentheses along with the 4 like the previous problem. So the only thing being raised to the negative 2 power here is not the negative sign out in front, but just the 4. And so therefore, to get rid of the negative sign on the exponent, only the 4 gets reciprocated in the denominator. In which case we'll have negative 1 over 4 squared. Now this is saying negative 1 over 4 times 4, or this is saying negative 1/16. So notice there is a night and day difference between these two answers here. It looks like these problems are the same, but they're not. Again, back up here, the negative sign in front of the 4 is also being ultimately raised to the second power. But here, the negative sign just comes along for the ride, and only the 4 ultimately is raised to the second power. So you got to be very careful when raising negative numbers to even powers. Okay, you can get into trouble if you're not careful. All right, let's look at another one here. If we have 5y to the negative 2 power, all of this is understood to be over 1. To simplify this expression, only the y gets reciprocated down into the denominator because it's only the y that's raised to a negative exponent, not the 5. So the y comes downstairs, the 5 remains up in the numerator, in which case we'll have 5 over y to the positive 2 power. And that would be your simplified result for that problem there. Okay. All right. Contrast that problem with this one here. If I have 5y inside parentheses raised to the negative 2 power, now this is saying something different. Okay. This whole quantity is understood to be over 1. So what this is saying here, to get rid of the negative exponent outside the parentheses, is everything inside the parentheses must be reciprocated down into the denominator, in which case we'll have 1 over 5y raised to now the positive 2 power. And this then, to further evaluate, is saying 1 over 5y times 1 over 5y. 1 times 1 in the numerator is 1, and the denominator is 5y times 5y, which is 25y squared. 25y squared, because y times y is y to the second power. 5 times 5 is 25. All right, a couple more. Let's try to simplify 2 to the negative 5 power divided by 2 to the negative 3 power. Now, when we're dividing like bases, we keep the base the same and then we subtract the exponents. That's what the rule of exponents is for division of like bases. So the base of 2 remains the same, and we take the numerator exponent and subtract off the denominator exponent. Be careful with your signs here. Subtracting a negative 3 is the same thing as adding a positive 3. So this is equivalent to 2 to the negative 5 power plus 3, which gives you 2 to the negative 2 power. Now, you don't want to leave your answer looking this way because we have a negative exponent in our result. So we want to get rid of the negative exponent. To do that, we need to understand that this quantity sits over 1. We reciprocate the base 2 down into the denominator, in which case we have 1 over 2 now raised to the positive 2 power. And this is now saying 1 over 2 times 2, which is really 1/4. And so that would be the final simplified result of our problem back over here. All right, how about x to the negative 6 multiplied by x to the 8th power? When we multiply like bases, we keep the base the same and we add the exponents. So negative 6 added to a positive 8 gives us an exponent of positive 2. So our final answer, or simplified result for this problem, is x to the positive 2 power. All right, how about if we have x to the 5th power cubed divided by x to the 10th power? All right, in the numerator, notice we have a power being raised to a power. And we raise a power to a power, we multiply the exponents. So x to the 5th power raised to the 3rd power is going to be x to the 5 times 3 power. And this sits over x to the 10th power. So in the numerator, we're going to have x to the 15th power, and that's going to be divided by x to the 10th power. Now, ladies and gentlemen, we shift gears because now we're dividing like bases, and therefore we have to now use a different rule of exponents that says when we divide like bases, we keep the base the same, and we take the numerator exponent and subtract off the denominator exponent. Final answer is going to be x to the 5th power, and that is your final simplified result of the problem we began with. Now let's try another one. X to the 2nd power raised to the negative 3rd power, all divided by x to the negative 5th power. First, we will simplify the numerator, realizing that we have a power being raised to a power, in which case we are to multiply the exponents. So x squared to the negative 3 power is x to the 2 times negative 3 power, and that'll sit over x to the negative 5 power. In the numerator, we now have x to the 2 times negative 3 power, which is x to the negative 6 power, and that is divided by x to the negative 5 power. Now when we divide like bases, we keep the base the same and we subtract the exponents, taking the numerator exponent and subtracting off the denominator exponent. So we have x to the negative 6 subtract negative 5 power. In which case we will have x to the negative 6 subtracting a negative 5 is like adding a positive 5. Hence we have x to the negative 6 plus 5 power, which is x to the negative 1 power. But again, remember, we don't want to leave any negative exponents appearing in our final answer. So we have to get rid of this negative exponent here. We realize this quantity sits over 1 understood. To do away with the negative sign in the exponent, we flip or reciprocate the base x down into the denominator, in which case our final answer is 1 over x to the positive 1 power, or 1 over x. And that is the final answer for that problem there. All right, let's look at a couple more here. About x to the negative 2 power divided by x to the negative 5 power. And this whole quantity is raised to the 3rd power. Now there's a couple different ways you could do this problem. We could work inside the parentheses first and divide these like bases of x. Hold on, we're losing our focus here a little bit.